welcome back. We are going to look now at a catalyst, right? And for this, I'm also going to need a little bit of a bigger video. And then I'm going to do my best to try and demonstrate how a catalyst works, right? Let's talk about it in theory first. In theory, a catalyst works by aligning particles so that on a catalyst, aligning particles on a catalyst such that any collision that occurs on a catalyst is effective. Now, effective collisions is where we have enough energy. What? Energy. We have enough energy, right? And also the correct orientation. Okay, so let me do this. Let's see. This is what I'm going to call now as my catalyst, right? Do we all see the catalyst? It's a book, right? I'm just using a book. Let's use the book like that. And I'm going to use the book to serve as a catalyst, to give you an idea. Now, I don't have enough hands to make this thing work really, really well. But let's say this is a particle. This is a particle, and this is a particle. The particles, they move around. They move around, right? They move around. They move and they move and they move and they move, and they're in this vessel and they want to collide. But they don't collide, so we need them to collide, right? Okay? Maybe they collide, but the collisions are not effective. What the catalyst does is the catalyst will come up and find these particles. So let's assume that this particle is moving there and this particle is moving there, and they're just moving around and floating. The catalyst comes and comes and comes, and it slowly comes, and then it finds them. And then as it finds them, it lines them up. So here, let's just move the camera a little bit. The catalyst comes, it's already, this particle is moving here maybe, and the catalyst found it, right? So it continues to move on there, and the catalyst finds this particle as well. And then it puts both particles on the catalyst. Okay, so now that we have both particles on the catalyst, let's just see if I can get I can't get an image there. These two particles will have to move, right? And as they move on the catalyst, anytime that they collide, because they are already aligned, anytime that they collide, it will be an effective collision. Can you see? This thing is moving on the catalyst, that one's moving, and as they come, they knock one another. There we go. We have an effective collision. And that's really the job of a catalyst, okay? And yeah, so you will see some animated videos in the next section that shows you exactly how this works, right? So that explains the theory behind it. The catalyst will find the particles and it will align them to ensure that they have the correct orientation, and thereby ensuring that any collisions on the catalyst are effective collisions, right? Because we already have the orientation. That's basically how a catalyst works. It finds the particles and holds their hands, and it helps them knock into one another. Okay, so that they can start the activated complex and make a baby. Okay, now there's one thing I didn't talk about. I didn't talk about pressure, but I did say an increase in pressure increases the rate of reaction. So let me briefly talk about that. From grade 11 or even grade 10, you should know that an increase in pressure occurs by decreasing the volume, right? What is something that's pressurized? It's when particles are close to one another. They are easily in contact with one another, or the probability of them colliding is very, very high, okay? So if I take a vessel, and let's say we are standing in this room, and the room is the room is our vessel, right? And I decrease the area of the room, the volume of the room. In other words, I'm standing in a room and all of a sudden the walls start closing in on me. Just imagine that, right? And there's a few people in the room. As the walls start closing in on us, we obviously have to get closer to one another. And this is when we say that the room would be pressurized. There would be more pressure in the room. And so how do you increase the pressure? You decrease the volume. They are inversely proportional. As a room gets bigger, the pressure decreases. As a room gets smaller, or the vessel gets smaller, the pressure increases. Now, think of collision theory. Think of this in terms of the collision theory. If you have a smaller room and you have 10 people in that room, isn't it more likely that when the room is smaller, those people will most likely collide? They'll walk into one another because they can't easily avoid somebody. And that's really what's happening in the case of pressure. We increase the pressure by making a room smaller or decreasing the volume. Okay, so I've spoken about concentration, I've spoken about a catalyst, spoken about temperature, we've spoken about the surface area, and we said the nature of the reactants is purely based on the chemical makeup. Okay, so that concludes the video on the basics of the factors affecting the rates of reaction. The next video is actually by one of the other YouTube channels that will show you how to measure different rates of reactions using different tools.